Afternoon, good morning, wherever you are in the world, and thank you for coming along to this Trees and Design Action Group seminar. TDAG is a network and a forum that brings together people and organisations to support the role of urban trees through better collaboration in planning, design, construction, maintenance of our urban places. Evidence-based information and knowledge exchange is really important to us, as is growing the research base and making sure that the research we do feeds into practice. So thank you very much for coming along today. We really encourage your questions and your participation. I'd also like to thank the partners for this particular event, which includes the Chartered Institute of Ecology and Environmental Management, the Landscape Institute, the Mersey Forest, the Town Country Planning Association, and the Green Infrastructure Partnership, and the Urban Design Group. Wow. So without any further ado, I am going to introduce the chair for today, which is Dr. Susanna Gill, who is the Research and Policy Lead at the Mersey Forest. So I know Susanna's name because when I first started working on my research, I kept coming across this S. Gill, and I kept thinking, who is this person, this S. Gill? So I'm really pleased to now be able to work and collaborate with Susanna. She's based at the Mersey Forest, where she's been since 2006 after completing her PhD on climate change and green space at the University of Manchester. Most of her work is on the interface between research, policy and practice, which is why she'll be such a superb chair for today. Over to you.
Thanks, Emma. And thank you. It's a pleasure to be here today and to chair this seminar. We've got a fantastic lineup of early career speakers who'll give us insight into their urban tree research and how it can inform our practice. So, as Emma said, I'm Susanna, I'm Research Policy Lead at the Mersey Forest. For those of you who don't know, the Mersey Forest is one of England's community forests, one of 15 community forests and part of the Northern Forest Initiative. We're based in Cheshire and Merseyside, and we've been going for about 30 years, increasing tree cover across the area over that time. So in that time, there's been 10 million new trees in the landscape, which is equivalent to 4 trees for every person living there. And we work with partners to make this happen, so it's not us on our own. It's a lot of organisations from our local authority partners through to local communities and businesses. And I guess the point of it all is not just about the trees in the landscape, it's about bringing trees for people, for nature and for the climate benefits that we can get from them. So we've recently established our Mersey Forest Ideas Lab, which is bringing together researchers to use the Mersey Forest as a living lab and really try and get research impact for them, but also to improve our ongoing practice and ensure that evidence underpins everything that we do. So it was a real pleasure to be asked to sponsor today's event and today's prize for early career researchers. We are going to hear from 6 researchers today who are all in the early stages of their career. And I guess, why is this so important for us at the Mersey Forest, and I think for all of us here today? Obviously, urban tree research is really crucial because it's within our urban areas that most people are concentrated now, where we live and where we're increasingly disconnected from nature. So it's here where the benefits that trees can bring can really be felt by people, where we can help to reduce inequalities that exist in the distribution of tree cover throughout our neighbourhoods. And also arguably where there's a lot of challenges that we have to overcome in order to try and increase tree cover. So urban trees are not nice to have, they're essential, and it's essential that we do overcome these challenges and find ways to bring more trees into the urban realm. Trees themselves in the urban realm also experience more stresses, or a different range of stresses. So we need to understand those and find ways to ensure that our urban trees thrive, bring us the benefits that we want, and help us to recognise that we've got a reciprocal relationship with those trees and we get benefits from them, but we also need to look after them. I think the focus on early career researchers today is really important because it gives them an opportunity to interact with the wider community and put questions to you, and to share their research with practitioners. And I guess their research, we're supporting the next generation of research that's going to underpin all of our ongoing work. So as to start our day today, I wanted to hand over to Cecil Konijnendijk, who I'm sure many of you will know. He's the director of the Nature-Based Solutions Institute. He's got a distinguished career in research himself, education and practice, and in all aspects of urban forestry. And in recent years, he's proposed the 330-300 principle that I think many of you will have heard of. And he's going to talk today about the importance of urban tree research and its benefits to practice, the 330-300 rule and other stories. So over to you, Cecil.
Thank you so much, Susanna, and well done on my last name. That was impressive. I've never heard it so well said apart from Dutch people. So that's really great. So wonderful to see so many people join. And of course, the real stars of the show are the early career researchers, colleagues that we'll hear from later. I have to apologize, I have a little cold, but I think I will have a voice that will hold up for 15 minutes or so. So yeah, the importance of research, and I think Susanna already eloquently highlighted why it's important. So I thought I'll give a bit of perspective from my side of things, as someone who is really working at the policy science interface, you could say, really trying to package the research more and more for decision making and for practice. I think we've seen, of course, over the years, I would say an expanding influence of organizations, global organizations, national, European, that have been trying to push research on urban trees, on urban forests, and also often with a more applied focus. So really trying to find research that can help those of us who are planning, designing urban forests, who are managing them. So you see here some examples, some of the networks and organizations you'll probably be familiar with. I think one of the key things that we've seen over the last decades as well is that we have a number of journals that have emerged. Some of them are really purely arboricultural, urban forestry focused. Some are a little bit broader, like Hort Technology. And of course, yeah, it's almost 30 years ago, we launched this journal called Urban Forestry, Urban Greening, which yeah, has rapidly become one of the main avenues as well of urban tree research. And I think the fact that journals like this receive yeah, 1,000 or so manuscripts a year now show, of course, that we are really seeing a really interesting time for tree research worldwide, urban tree research worldwide, more and more studies, more and more high quality studies. And I think also we see more parts of the world being active in urban tree research and publishing about it. So after my time as editor of Urban Forestry, Urban Greening, I had the pleasure to step to another journal, the Journal of the International Society of Arboriculture, which is now called Arboriculture and Urban Forestry. And yeah, we've really been trying to lift this journal a bit up in this competition between journals, but especially also to make it more accessible. So it's now fully open access online, so everybody has free access to the articles, irrespective if you're a member of ISA or not. And it also means that you can publish for free. And I just wanted to show you from our website some of the latest articles. So you see things about stormwater soakage wells, deep root zones, but as well a study from Brazil on the 330-300 guideline. And if you look at the top topics there on the right, you see also it's a pretty wide-ranging suite of topics from cooling, tree mortality, some very specific interventions to deal with pests and diseases. And one of the most popular studies I think we published over time is the cost of maintaining or non-maintaining trees, which is of course a big topic as well. So I think where research has really played an important role is to emphasize the importance of urban trees and urban forests. This is now, yeah, of course, popping up in all kinds of publications and policy documents, but there's quite some decent research now underpinning many of these values and benefits of urban forests. And just to give you an example of that, the whole area of urban forest and climate change, Susanna already alluded to it, means that we have much more information today about mitigation impacts of urban trees, also how trees can help adapt cities, communities to climate change. There's the whole interface between public health and climate change, heat waves and how these affect people. And this is actually also an area of research that has really been developing. Plus, of course, also urban nature, urban trees is impacted by climate change itself. So this is sometimes a bit forgotten. It's like urban forest is this panacea that can help us deal with climate change. But of course, on its turn, the urban forest needs to be healthy and vibrant, and that can be a problem with climate change. And I think in line with this, we see also a recognition increasingly also outside of the green professions that urban nature, urban trees provides critical infrastructure, so essential infrastructure for our cities. Another area I think that is really has been booming during recent years is the whole public health nature interface. We did some study here for the Flemish government where we try to package all the wonderful studies that are available on the health effects of trees and nature. And we found that interventions like increasing canopy cover, having more pocket parks, more community gardens, as well as greener schoolyards are some of those areas where you can actually have the biggest and the quickest wins for mental health, for physical health, social health, but also, for example, children's learning. And I think this shows you that the research is such a solid place that we can actually give these kind of policy recommendations that are also then taken up, in this case, by the Flemish government and by municipalities throughout Flanders. I think you would probably agree with me that one of the major things that happened in terms of connecting research to practice is the whole kind of economic evaluation of urban trees and their benefits. And of course, here iTree played a really essential role. The product developed by the US Forest Service, that, in many cases has really raised the level or the interest in urban trees in cities across the world. But we've seen other studies, for example, commissioned by the Arbor Day Foundation on the economic effect of the urban forestry sector. This wonderful study from Central Park in New York, which gives a really detailed overview of all the different economic benefits of having that park there. Think about tourism taxes and real estate values. And also quite a lot of studies now that are looking at the health benefits of living in the green neighborhoods. This study from California, together with a big healthcare insurer, showed that actually people living in green environments spend up to $374 a year less on healthcare costs. So these are significant figures, and of course this is just probably an underestimation of the immense benefits of having nature and trees close to us. So I've been trying to think for this presentation a little bit, some of the emerging topics, some of the things that I really see popping up in research papers more and more. There's the whole area of technology, of course, of smart inventorying, which is really taking off also in terms of the number of startups and companies. And of course, AI and the impact that artificial intelligence will have on decision-making in urban forestry. Quite some studies on governance and collaboration coming up, also from different parts of the world. Of course, continuing work on tree selection and establishment, especially also for future climates. How to integrate trees in dense urban settings, trying to be creative, find technological approaches to still having trees, also when areas are very dense. A topic that I really like myself and that I also see more and more in focus is biocultural diversity. So the linking between cultural diversity and the different connections people have to trees and nature with also the biological diversity. And how then actually people and nature co-create, co-shape urban landscapes. And then also definitely important is the whole area of economics, resources, funding streams, especially for long-term management of the urban forest, where of course there's a tendency to focus more on capital investments, on tree planting, which is really attractive for the politicians. But what can we do also to improve management on the longer term? Just to give you some of the studies I've been involved with over the past few years. Governance, we do a lot of governance research. This is work done by a PhD student of mine, former PhD student, Na Yao from China. And she did a really interesting study on the big Beijing afforestation program, where they've planted 100 million new trees in the Beijing region, trying to find out who are actually driving this, who are the players. And even in a kind of top-down system, it turns out there's a lot of governance actors, different public bodies that are trying to influence the procedures, while there, for example, are farmers and landowners, or actually land users because they don't own the land, who all of a sudden find themselves as forest managers rather than farm managers. So really interesting to dig into those mechanisms. Just some of the other really interesting studies that I've had the pleasure to be involved with had to do with things like green space branding, how cities are using green and trees to promote themselves and to attract funding and tourists. We looked at fear of crime in a multicultural society in Malaysia. We looked at smart urban forestry and the use of technologies. We had some really interesting studies on children in forest school environments, preschools, and how being outside in forest meant for these children that they would be more creative, less aggressive, more social. And finally, one of my personal favorites is a study by Trine Plambeck on nature and creativity, where she looked at the influence of trees and green on the creative process of artists, of writers, sculptures, and so in Denmark. So some really interesting findings where everybody basically agreed when they have to be creative, when they have to be receptive for new ideas, everybody goes out to nature. So that was pretty clear. I think one topic that is really gaining more traction as well is the whole idea of urban soils and the connection between soils and trees. This is some work we've been doing in The Hague, trying to look at soil improvement for small forests and small tree plantings. But we also, apart from doing more technological work, involve children, school children, and let them be active and monitor the soil, see the number of earthworms that is developing in the site, etc. And this really creates nice links as well between these children and the new emerging tree plantings. I think some of the key aspects that I've really taken on in my current work, which is very much now, hoping to impact policy and also working with policymakers across the world, basically, really the need to let trees grow old and large, also in our cities. So that means good sites, good establishment, and good maintenance. Bringing trees and green close to people. The importance of green views is more and more also a topic of research. We need to offer a variety of tree and green experiences and enhance the tree canopy, as I said earlier. But of course, also deal with some of the potential negative impacts that could be associated with living close to trees. Think about allergies or maybe some pests or diseases. And definitely also, focus on this more diverse and resilient urban forest. So moving to my last few slides, just one story, of course, is that of the 330-300 principle. For me, that was really a way of packaging a highly complex research field into 3 simple metrics. And of course, it is an oversimplification. But practice has shown that actually policymakers, practitioners are looking for guidance that is clear, that has some kind of evidence underpinning. And from there on, you can then have more nuanced discussions on what is the design saying about this, what can we do, what's the local ecosystem, socio-ecological context. This 330-300 is really has gone viral and is now used even in the Dutch elections that we had last week. 4 or 5 out of the 15 parties had it in their election programs, and the number one party, D66, that got elected, they actually had it as a prominent part of their housing policy. And of course here, the health aspects are important, the climate aspects are important, and I think the idea of having the research underpinning this is really essential. And there I think, looking at some of the theories that can support the work, for example, the environmental pathway model is really a great example of that. So this is developed by Terry Hartig, a professor, environmental psychologist in Sweden, who looks at the idea that nature can impact our health by reducing harm, by restoring capacities, building capacities, but also can sometimes cause harm. And then for the 3 and the 30 and the 300, you can actually link specific health implications of having trees inside, having 30% canopy cover in your neighborhood, and having a green space, a high quality green space, publicly accessible within 300 meters from where you live. And of course, in the UK, we see similar kind of metrics and similar kind of principles. For example, the biodiversity net gain principle, which has been rolled out, and which has basically a scoring system for biodiversity, saying, well, okay, if you have a certain level of biodiversity before development, then after the development, you need to have a gain, you need to have a 10% higher biodiversity, and you have to make that very plausible using that scoring system and showing how you're going to intervene in the site to promote biodiversity. And in the Netherlands, we also developed something called a national tree norm, again, based on evidence, where we focus on tree canopy volume or tree crown volume, rather than looking at a kind of a 2-dimensional tree canopy perspective, because of course the benefits of the tree are really in the full crown. And here we can set certain levels of minimum crown volume that would be required per square meter or per neighborhood to make sure that these ecosystem services are provided. So just some examples of how research is now taken and put into these kind of metrics and guidelines. I think also interesting, and this is really finishing up, organizations like the Sustainable Forestry Initiative in North America, they actually developed an urban and community forest sustainability standard, again, based on really the best of the research, showing that what you need to do to have a good forest management, urban forest management in place in your community, university campus, and then you have all these objectives and a whole set of criteria that you would have to fulfill, and then you would also get certified and get recognized. So yeah, this again shows how the research is feeding into management standards. So I think personally there is a bright perspective for research, especially as I see it being taken up more and more, getting a more respected place at the table, also among policymakers, engineers, planners, architects, etc. But of course, it doesn't mean that we have to stop doing the research. We still have a lot of gaps, and that's why I'm also very excited to see the studies that will be presented today. So thanks very much for listening, and I'll be very happy, I think, to answer questions if there's a little bit of time.
Brilliant. Thank you very much, Cecil. Have we got any questions from the audience at all?
You of course have got lots from me, but I shouldn't step forward.
Does anyone want to put their hand up and ask a question? Or would you like to give one of yours, Sue, to get the ball rolling?
Okay, so I think the 330-300 rule has really sort of caught the imagination. And so it's become a very easy win for politicians to say, yes, yes, we support that. Are you finding that they actually then do follow through and actually deliver in practice, or do they sort of ease back once they've sort of won the day, if you see what I mean?
Yeah, no, that's of course that's a great question, Sue. So I think both. So I've seen cities where they really actually follow through. So Malmö in Sweden is a great example of that, where they really integrated it in basically anything they do in the public realm, and even in the private realm. So there they really follow through in terms of planting new trees, moving parking spots away, creating new policies. But then of course I see lots of examples also where it comes into the programs and really not much is done, not much changes. I see also some cherry picking, so people take one of the 3 components and work with that, or make their own versions. So it's yeah, I think there's a bit of greenwashing going on as well, unfortunately.
I think we've got a question from Katie. Have we, Katie?
Yes, sorry, I can't, I'm having trouble putting my hand up. Yeah, it's so interesting what you were saying about how the research is feeding into policymakers in Netherlands, and I'm involved in our emerging local plan, and we're talking about tree cover and a lot of the things you do, but it would be really helpful as a resource to know how to pick up the evidence and how it's feeding into politics, just like you've explained, but as a resource for maybe councillors and policymakers in local authorities. I don't know, maybe that's already happening, but it just seems it would make us, when we're trying to do the best for our trees in our urban environment, to use what other people have done and the evidence that you've got. Thanks.
Yeah, thanks, Kate. I think that's a really important point, right? And I think, yeah, those stories of how it can actually be done and how it can be successful, I think are really important. I think TDAC has been doing some great work there as well to package the research and also follow through with working with local councils and so. But yeah, maybe we should find ways of compiling some of those experiences and making it a bit more hands-on as well for people like yourself who are in those positions.
I think
That'd be great.
A really, really useful thought, Katie, as well. I mean, one thing was struck me when listening to Cecil just then was the variety of tools and metrics that there are out there now, and what's the best way to package those up for example, a local authority. And yeah, I think we've got a good question. Have we got Helen? You're there with your hand up. Sorry, I'll let you ask your question.
Oh, hi. Yeah, this is just a little, because I was thinking exactly the same thing, Katie. So I'm actually a climate scorecards ambassador, and I don't know how many people here on the call know about the climate scorecards. Underneath the biodiversity theme, there is a clear question that asks exactly that, whether the council has a tree canopy cover as part of their strategy. That's something I'm trying to get my local authority to look very clearly at, because I think everyone in the room has probably seen the amount of prunus that go up and what that's doing for our tree cover, and, you know, healthy streets 20 years down the line is, you know, negligible. So yeah, I would definitely point to those climate scorecards at the local council, because they know what they are. and if they've got a sustainability team, they should be, you know, well up to date with it. The issue is getting all of these strategies up to date, and that's what I'm finding in my own local authority. It's about getting these policies and strategies that take into account, you know, latest best guidance. And of course, here in London, we've had the London Nature Recovery Strategy draft that's just the round of consultations just finished, and a lot of that, of course, is about these ecosystems and what it can deliver in terms of tree cover.
Thanks, Helen. And Jane, you've got your hand up, I can see.
Hi, thanks for taking my question. Cecil, that was a really interesting presentation you just gave us. I'm a landscape architect, and I've been the past president of the Landscape Institute, and we've been really pushing the urban greening and leading with landscape. And one of the issues that we talk about a lot is the health effects of greening our neighbourhoods. And there's a correlation between low canopy cover with poor health outcomes. But there are lots of other factors affecting the health of a local population. And I was just wondering if you had taken any of those into account when you've been measuring the healthy outcomes in relation to trees, you know, the issues around poverty and so on, and education. I'd just be interested to know how you've considered those when you have been looking at the health effects of trees. Thank you.
Thank you, Jane. That's a great question. Yeah, so myself, I have to say I haven't done so much research on that, but some really excellent studies have been undergoing or going on here in the Netherlands. So they have done, for example, a really great study on the 330-300 and physical health, but they also look at factors like, as you say, yeah, poor health, cultural background, all these kind of factors, and try to really tease those out. And yeah, things are complex. So you see in some of the studies that people don't like having a park nearby. And if you then go a little bit deeper in that, it has to do with the quality of the park. So that's why I always say, yeah, for the 300, there has to be a high quality, safe space that people really appreciate. But of course, the diversity of preferences and so do play in. I would say the patterns still point clearly at the fact that people do appreciate having trees and nature nearby. But underneath that, there's definitely a complexity, I think, that needs to be addressed in greater detail.
Great, thank you, Cecil. There's a lot of questions that have come through in the chat now, but unfortunately we're going to have to move on to the next part of our seminar today. But Cecil, if you want to take a look and respond to any of those, then feel free to chat.
Thanks, everybody. Thank you.
Thank you. So now on to, I guess, the main body of today's seminar. We're going to hear from the 6 early career researchers in turn. So these 6 people have been shortlisted from an open call for submissions, and we were really impressed with the quality and breadth of the submissions that we received, and felt that the ones we've chosen today really represent some of the range of urban tree research that Cecil was pointing to in his presentation, and I think they should be of great interest for our policy and practice. So each of the researchers posed a question that they would like the audience to ask of the audience. If you can take the time while they're presenting to respond to those questions, that would be really brilliant for them. If you can include their name, that would be helpful for us to sort of sort through the chat afterwards and piece it all together. And as Emma said at the outset, if you include your email address, then they can also directly contact you to carry on that discussion. We're not going to take questions immediately after each presentation, but we'll have a bit of time at the end for questions that can be put to any of them. So please do put your questions in the chat along with who they're for as well. And then after all 6 presentations, you're going to be given a chance to vote for the winner, who you think should win the TDAG Mersey Forest Ideas Lab Early Career Researcher Prize. So keep that in mind as you're listening. So I will hand over to our first speaker today, who's going to be Isabella Bhoan from WW+P Architects. and she's going to present on her work, Learning the Land Digitally, and LIM. So over to you, Isabella.
Thank you very much, Susanna. I'm just going to share my screen. Okay, this one up. Hello, everyone, and thank you for listening in today. I'm very excited to share with you all our work we've done at WW+P for learning the land digitally through our in-house service tool called LIM Aboris. So in general, cities are under pressure, and across every discipline, there's a pressure to deliver greener and more resilient cities. But what we found is that it remains elusive, both the proof of benefit, but also the proof of compliance and proof that the investment in nature delivers measurable change. And it's building upon what Cecil just told us. You can see even with the UN Sustainable Development Goals that they call for cities that are inclusive, safe, resilient, and climate responsive. Even the new urban agenda reinforces this through nature-based and regenerative approaches. Yet we find that implementation remains quite slow in the design process and in the delivery of the urban spaces and design. And most cities are still shaped through very mechanistic rather than ecological frameworks. So I propose that the challenge is actually no longer whether cities can grow, but how they can adapt. Technology defines the pulse of urban life in today's world. I would definitely argue every building, every streetlight generates data, and the same systems that mapped our world made it more efficient, but perhaps not so much adaptable. They optimize the built environment while they leave ecological processes still quite unseen. But we've already learned from these digital frameworks, and these digital frameworks are very much a part of how the built environment develops. We have building information modeling that coordinates construction through data-rich 3D models. We have GIS that turns space into evidence, revealing relationships across terrain, use, and population. And even digital twins are now getting into this urban environment and pushes even further, connecting live sensor data to models that evolve in real time. But what we are proposing is that environmental data, such as microclimate simulations and species behavior, could be integrated into design workflows. Cities might actually begin to operate as responsive ecological networks. Digital models could be used to simulate how tree canopies cool streets, or soils absorb runoff, or even vegetation densities and how it influences biodiversity and comfort, transforming landscapes into measurable performance through this digital space. LIM builds on that same intelligence as we saw in the original frameworks, but is now tuned and focused on the living world. It doesn't model steel or concrete, it models trees, soils, microclimates, and their behavior through time. It translates ecological performance into metrics that designers can use and clients can be empowered by. Each simulation becomes a small act of listening, understanding how the site actually breathes, how heat moves, how water travels, how shade shifts across the surface. So LIM Aboris, as mentioned, is our in-house service and is being developed through a digital software. It sits within standard design software, but instead of generating only form, it generates climate intelligence. It works through these 3 layers: microclimate impact assessment, modeling species-specific carbon, shade, runoff, and wind behavior, and regulating ecosystem services, quantifying the measurable benefits of those effects, and then pulled into the design guidance for the landscape architects or architects in general, identifying which species or nature-based strategies best functions for that site-specific challenge. The workflow is cyclical. It has baseline, scenario metrics, and then a feedback loop. So first we capture the existing conditions, the air temperature, the surface runoff. Then we test the future proposals, alternative planting patterns, species palettes, green infrastructure layouts. We extract the performance, how much carbon is sequestrated, how much air is cleaned based on your design. And then the data kind of falls back into the design, informing how you can optimize. So iteration becomes you would almost say, intelligence. The design learn as it evolves. And what emerges for us is actually a living database, families of species linked to quantifiable co-benefits and embedded into our digital software. So let's say you substitute a single tree species and the whole system recalculates the carbon capture, shading performance, and runoff potential and habitat value. So each change becomes a measurable ecological event in the digital space. This turns landscape from perhaps intuition-based into a computational, but very much still human, but informed by ecological intelligence and evidence based on that. So we tried out LIM in our pilot project at Hereford Station. We were to design the forecourt in front of this grade 2 station. And this was really where we were testing how ecological performance could coexist with heritage and infrastructure and urban design. The question was how to plant meaningfully in a space dense with infrastructure and regulation. So LIM simulated species growth over time, height, canopy spread, shadow casting in a perfect world almost, if you could say. But this was really allowing us to protect the heritage view while still justifying for the number of trees proposed in the design. For once, trees were not really aesthetic liabilities anymore, but they were quantifiable assets, which we could also convince the client and the stakeholder of. And from the model, we extracted much more data than just the growth. We looked at how the design was generating over 105,000 liters of water runoff avoided each year, about 1,000 kg of CO2 sequestrated, or even 5.6 kg of air pollutants removed, temperature reduction, wind reduction, and even biodiversity net gain. Every number backed by embedded species-specific data designed for our proposal. Not a spreadsheet that was added later, but actually a part of the design. What this enabled was precision, planting aligned with a purpose. Some species were selected for carbon capture, others for pollution removal or pollinator support. So the result was really a habitat that grew from data. Design becomes a form of negotiation between human need and ecological logic. And LIM really showed us the ability to direct the landscape design, what plant species are missing to support this specific local wildlife, or what habitat is needed to accommodate for life. Maintenance projections are often where sustainability or sustainable design fails in landscape architecture. Too costly, too complex. So LIM really helped us and the client visualize where we could do cost savings, where we could do optimized maintenance as well. Economic matrix, estimate environmental and maintenance cost savings, and resource use reductions. Naturalized regimes like wildflower meadows and rain gardens offered up to 60% maintenance reduction in cost compared to traditional planting. It reframed the discussion also from green is expensive to green is intelligent. In the end, the Hereford Hub became a small proof of concept and really initiated the further development of our product or our software. That trees, soil, and water, when quantified, can speak the same language as engineering or finance. It demonstrated how every ecological gesture, even however small it may be, has a ripple effect measurably in temperature, carbon, water, and even cost. And that's what LIM really is, not a software, but actually a translation of what is already happening, a way to let nature participate in the design conversation through its own metrics and data. So we're in continuous evolution with LIM. We are hoping to, on long-term, integrating IoT sensors and with some of, for example, the Hereford design when constructed, so we can create a feedback loop and measure the actual biodiversity net gain, the microclimate feedback from the built projects. We're building a system that can learn from its own outcomes, a feedback loop between the digital and the living. And imagining planting schemes that can refine themselves over time, learning which combination thrives, which one fails, which cool faster or costs less. And that's where we're hoping to get. The core idea is simple. Cities already have digital twins, replicas of concrete and steel. We are building the ecological twin, a digital framework where nature is not background, but infrastructure, where every tree, every surface, every drop of water can tell its own story. So if data built the city, maybe data can actually also help it breathe again. Thank you so much for listening in.
Thank you, Isabella. That was an excellent start to our presentations today. So I won't take questions now, but if you do have questions, please put them into the chat. I've got a lot of clapping hands coming up on the screen. It's nice to see. Our next presentation is going to be from Will Leaning from the University of Sheffield. He is going to present on his work predicting the impacts of climate change on urban green populations and urban community forest strategies. So I will hand over to Will now.
Thanks for that, Susanna. Yeah, I hope that's sharing nicely for everyone.
Yeah, it's good, Will. Thanks.
Perfect. Yeah, so good afternoon, everyone. So my name's Will, and I'm a second-year PhD student in the School of Architecture and Landscape at the University of Sheffield. I'm really pleased to be here because this is actually the first talk I've given on my research, and to be doing so with TDAG, it's something I wouldn't have imagined at the very start of my PhD. I should say up front that I passed my confirmation review yesterday, so that's my first year check. My project is feasible. So whilst I can't yet kind of go into the finer details of my planned methods or any results, I just kind of wanted to share where my research has come from and the problems that I'm hoping to address. So just a bit of background on me. I'm a biologist, or an animal biologist who actually found their way into trees. So I began my career in ecology, but soon realized I was much more interested in looking up. So I moved over into arboricultural consultancy after completing my level 4 in arboriculture and getting my climbing ticket. I've also spent quite a lot of time in practical conservation, planting thousands of trees across the country in all sorts of environments. But over time, I was noticing a pattern. Despite our careful planting and management, many trees just didn't seem to be thriving, even in places where we deemed them to be incredibly suitable. Some failed early, whilst others were struggling in what should have been these ideal conditions. And it's kind of this observation, that there's something beyond our immediate management that might be influencing tree success, kind of really sparked my curiosity and set me on the path towards this research. So as I'm sure I'd have to remind you all, urban trees provide us with a huge range of benefits. They regulate our temperature, they help reduce flooding, they clean our air, and they make our cities far more livable. They're one of the few parts of our built environment that actually improve and become more valuable over time. But urban trees are under increasing stress. They're expected to deliver climate adaptation benefits while being directly affected by climate change themselves. So we're already seeing higher temperatures, longer droughts, and more intense rainfall events, all of which are kind of adding to the stress and strain of trees that are already kind of growing in these tough artificial environments. So yeah, these urban areas, they present some of the harshest growing conditions kind of trees would face. They've got compacted soils, limited rooting space, high heat retention from the impervious surfaces, and there's a lack of kind of the natural cycles that we'd expect in more natural forests. And all of these pressures combine to reduce the health and lifespan of our urban trees. So past studies have shown that the average lifespan of an urban tree is somewhere between 19 and 28 years, and that has recently increased, but it's far below what we'd see in more natural settings. So from a small pilot study that I ran this year, I found that 40% of some species were dead within just 15 years. And that aligned with a recent Fund for Trees report, which found kind of annual mortality rates in urban areas are around 5 to 7%. And to put that kind of in kind of illustrated terms, if you started with 100 trees, after 30 years, only 20 are expected to survive. And of those 20, only a handful are going to be kind of thriving and in good health. And now that's assuming that our climate isn't going to change, which of course it will and is. And these projections are suggesting that our urban forests are facing a very real threat, one that can't be solved by kind of post-planting management alone. So ensuring that we have kind of these healthy and resilient urban forests in the future isn't something that can be solved by one person or one discipline. There's environmental, social, and management factors that are all interacting in complex ways. But I saw an opportunity to contribute to help build those stronger and more localized evidence to our urban areas to help make more informed decisions on species selection, and to do so in a way that kind of gives the trees the best chances to thrive and not just survive. And at the very heart of every urban forest is the species themselves. So when I started digging into the science behind species selection, I noticed that most of the research predicting where trees can grow is done at very broad scales across countries or even continents. That's really useful for our general understanding, but cities are very different environments to this. You know, they have unique microclimates, compacted soils, restricted rooting spaces, and then the mix of complex human pressures and management regimes that just simply aren't captured at those large scales. So I realized there's a clear gap here. We don't yet kind of have enough evidence that specifically tells us exactly which species are most suitable for specific urban locations, kind of not just theoretically, but also in practice, kind of using that real world conditions our trees are facing every day. And then whilst we often model or predict kind of how our trees are going to respond to future climates, the predictions are rarely actually then compared against what's actually happening to our trees on the ground, like kind of right now. So in other words, kind of I like to say a model that says kind of oak trees in Sheffield aren't performing very well is not a model we should be listening to. We're kind of missing that link between the prediction and kind of the reality, what a model says should work and what we are seeing or indeed failing in our urban areas. And then finally, I realized that species selection, you know, isn't just an ecological issue, it's a social one too. Kind of decisions are shaped by local policies, budgets, nursery supplies, maintenance regimes, and even personal preferences. I think Bhoan put it well in that we cannot fully expect to deeply understand the urban forest nor engage in the meaningful growth of our field without human perspectives. There was a 2022 review that found around 70% of our UK urban tree strategies kind of mention species selection, but a lot of the time it was using the vague terms like right tree in the right place without kind of explaining what that means in the context of where those trees were being planted, kind of what is the evidence behind that. Kind of in other words, just because a tree is working in one city and one place doesn't mean it's going to necessarily work well in another one. So my project is built around these gaps to identify which species are most resilient under future conditions, but specifically for urban areas, and then to understand how kind of that professional knowledge and decision making can influence and help which species can actually be chosen. So kind of what really excited me about this project, it was its interdisciplinary nature and bringing together my experiences in ecology, data science and practical arboriculture to build a methodology that works to my knowledge and strengths and applying it then within strategic areas of the Mersey Forest. So first off, I'm going to be developing a series of computer models that will show where different tree species are likely to exist, both now and under future climate scenarios. And these are going to incorporate a wide range of environmental data, but crucially, they're going to be tailored specifically for urban conditions, working at a much finer and more localized scale than typical global models. So they'll hold much more applicability in kind of our day-to-day on-the-ground work. But the models alone aren't enough. To ground these predictions in reality, I'll be carrying out detailed field surveys, kind of building on my industry experience and using established research protocols to assess the health of urban trees in situ. You know, this includes monitoring a range of stress signals, and the goal here is validation as well as checking on the current health of the Mersey Forest and help identify kind of the local factors that are currently influencing tree health and survival in situ. I'll also then be engaging with local practitioners and decision makers, people like yourselves, to help validate and interpret the findings. Kind of your experience is essential in actually understanding what's feasible in practice, kind of where problems might arise and what limits species selection and why. This kind of last and kind of most crucial step will transform that kind of modeled computer data into actual practical guidance that is based within the realities of how we create our urban forests. So ultimately, the aim of my project isn't just to create another series of complicated models, but to produce usable evidence-based recommendations for species selection localized to the Mersey Forest region. And then the plan, I hope, for these findings, you know, is just to support kind of the improved planning of our urban forests, which will have a range of knock-on benefits. Think, you know, reduction in costly failures. Trees will be less likely to be of poor health, which will increase kind of the aesthetic value of our urban forests. The range of climate mitigation benefits will be retained. And most importantly, hopefully our canopy cover should increase as tree turnover decreases. And that'll help to ensure that the trees we plant today, you know, are still standing and thriving decades from now. Kind of ultimately, it's about adding kind of to the industry shifting away from counting trees to kind of planted to ensuring that the trees we plant actually survive and deliver the benefits we rely on. And then beyond this work, I believe that there is opportunity to expand our planning knowledge at the intersection between science, practice, but integrating the kind of community perspectives, which I think, if we properly harness those, it's going to lead to the creation of urban forests that people actually truly value, care for, and defend. So just to wrap up, urban trees are one of the few parts of our built environment that actually grow in value over time, but only if they survive and thrive long enough to do so. And there is a need to kind of intricately understand the nuances of the urban environment in their growth and survival. Every decision that we make about which species to plant and where we plant it is shaping the character and comfort and resilience of our urban areas. Now, this is a quote from Gilbertson and Bradshaw, who were studying trees in the Mersey region long before me, really always kind of sticks in my mind through this project. It just kind of helps to remind me how complex the issue of urban tree survival really is, and that we're still working to improve our outcomes, 40 years later. So if my work, can even play a small role in helping practitioners such as yourselves and policymakers make those decisions kind of with greater confidence and ensuring that the trees we're planting today are surviving to be healthy, mature canopies in the future, then I'll consider it a big success. So thank you so much for listening. I am always kind of keen to connect with other people in the field. So please reach out to me by email or LinkedIn if you're interested in following my research. Thank you.
Thank you very much, Will. Another brilliant talk. So as I said before, we'll do the questions at the end, but please do respond to the researchers' questions to you in the chat. It's really helpful for them if you can engage with their questions too. So I will hand over next to Elle Smith from the University of Leeds, who's going to talk about her research, which is into the role of private garden trees and woodland covers for 330-300 success in 7 English cities. Elle, over to you.
Thanks, Susanna. Just share my screen. Is that sharing okay?
Yep, that's good, thanks.
Okay. So hi everyone. I'm really excited to present my work to you today, which is about the 330-300 rule in English cities. I'm a final year PhD student at the University of Leeds, but this work is in collaboration with the other organisations on the slide as well. So to start with, in England, many cities are setting ambitious targets for canopy cover. For example, Leeds has a target to go from 17% to 33% from 2020 to 2050. But this doesn't consider how these trees and their benefits are distributed across an area. It also doesn't account for green spaces, which are an important part of urban nature as well. So as we've seen, Cecil's 330-300 rule combines canopy cover and access to trees and green spaces into one assessment. While it does use canopy cover as a measure, the distribution of trees around people's homes, schools and workplaces is also considered. So in this work, there are 3 parts. Firstly, we've analysed the 330-300 rule in the local authority areas of 7 English cities. We've then examined the sensitivity of these results to different methodological choices. And finally, we examined how land use impacts success at the 330-300 rule. And I'll link to these objectives using the numbered icons throughout the slides as well. So various data sets were required for this work. For trees, we've used data from Blue Sky's National Tree Map. For buildings and green spaces, we've got these from Ordnance Survey. And for neighbourhoods, we've used lower layer super output areas from the Office for National Statistics. And these are areas where the population is between 1,000 and 3,000 people. So this figure shows the regions that were studied located on a map of England. And we looked at the local authority areas of 7 different cities, which are shown around the edges. And here, the green shows the full local authority area, and the orange shows the LSOAs that we studied. So in some cases, tree data collected in the summer wasn't available. And as we wanted to ensure the analysis was consistent, we only studied those LSOAs where summer tree data was available in full. And then of those LSOAs, we only looked at those classed as urban. So we measured success at the rule for every building in these LSOAs, and we used 2 different methods described as the simple and the detailed method. In the simple method, buffers were used for both the 300-metre and 3 tree tests, and this is shown in the figures. So in the 300 test on the left, a 300-metre buffer was applied around each green space, and buildings that crossed this were classed as passing the test. For the 3 test, a buffer was applied around each tree, so we've got 1 buffer shown in the figure, and buildings had to intersect with 3 different buffers to pass the test. And then to investigate the impact of how close trees are to buildings, we analysed buffers of 30, 50 and 100 metres radius for the 3-tree test. For the detailed 300-metre test, we used a network analysis to identify walking routes between buildings and green spaces using the Python package OSM-NX. And then if the walking route, such as the one shown in the figure on the left, was less than or equal to 300 metres, the test was passed. And for the detailed 3 test, we used lines of sight from windows that were simulated at 5-metre intervals around the outside of buildings, 2 tree points, and this follows the work of Crozo et al. And again, we altered that cutoff distance for these lines of sight to be 30, 50 or 100 metres. And then in this case, a building would have to have a line of sight to 3 different trees from any window to pass the test. And then similar to Crozo et al. And more recently Iqbal et al., we also used a grading system to identify an overall score for each building based on how well it performs in each component of the rule. So the scores go from 0 to 3 for each component of the rule to give an overall score from 0 to 9, with 0 being the worst performance and 9 being the best you can get. So then here we're looking at the variation in the LSOA average grading across those different methods and the 3 different cutoff distances for the 3-tree rule, which are along the x-axis. And the white dot in the center shows the median grading, and then the spread of the results around this is shown in blue. And so what we find from this figure is that using both a larger cutoff distance for the 3-tree rule and using the simple method over the detailed method lead to higher gradings. So this is important because the simple method might be used where there are fewer resources, as it's quicker and easier and also requires less fine-scale data. But as we can see, the method used will impact the results, with the simple method suggesting better performance. So it's important to know where the results have come from and to use a consistent methodology for fair comparisons between cities and to track changes in cities over time. In the rest of the work, I've used results from the 50-metre detailed method. So on this slide, I've got the results for each city analysed, showing the proportion of buildings meeting each component of the rule. And the grey shading shows the range of results from other studies that have analysed the 330-300 performance in cities around the globe. And the black line shows the average results from these studies. So what we see is that the English cities perform about as well as the cities in other studies for the 3-tree rule, with results for the English cities near to the average of the other studies. But the English cities do perform worse at the 30 and 300 rules, with all the results in this work below the mean results of locations in those other studies. And then looking at the proportion of buildings meeting all 3 components, in this study we found that Manchester performed the best, with 2.1% of buildings analysed meeting all 3 components. However, 2.1% of buildings is obviously still extremely low. And despite many of these cities working towards canopy cover and greening targets, these statistics show us that there are consistently low access levels to trees and green spaces across the English cities in this study. And so on this slide, I've got a Venn diagram which shows the results for all 7 English cities combined. And it shows the proportion of buildings meeting each component and the overlap of success with the other components of the rule. And the reason to show this is to highlight that only 6.2% of buildings met the 30% canopy cover rule, which is much lower than the totals for the other 2 components. And so this tells us that it is the 30% canopy cover component that is the main driver of this generally poor performance at the 330-300 rule across these English cities. So on this slide, I'm showing the spatial variation in the 330-300 results for Manchester, with the colours showing the overall grading in 1 hectare cells, and the score per cell is the average grading across buildings in that cell. So what we see in this plot is the yellow areas, which are the worst performing areas, often coincide with the urban centres and then the grading around these regions tends to improve in outward rings. And this poor performance is perhaps expected in these areas as they're obviously generally more built up, and so there's less space for trees and green space. But also to note is that lower greenness levels such as these have been linked to higher levels of deprivation. And then finally looking at how the land use of where trees are situated impacts success at the 330-300 rule on an LSOA scale. So we identified the land use of each tree and the amount of each land use type in each LSOA. And the land use types used were private garden, public green space, private green space, other green space, woodland, and road and street. And we then use this information to investigate how the land use in the LSOAs impacts the overall grading of the LSOA and the 3 and 30 components of the rule using generalized linear mixed models. So I won't go into details about the models, but just to look at the results of this land use analysis, for the proportion of buildings meeting the 3 tree rule, we found that the most important land use variable for success at this was the density of trees in private gardens. And then for canopy cover, we found that the proportion of land in the LSOA that's woodland was most important. And the figure in the middle shows the clear relationship between the increase in woodland cover on the x-axis and the increase in canopy cover on the y-axis. And so for overall grading, we found that the proportion of land in the LSOA that's woodland was most important, followed by the density of trees in private gardens. And as the grading is based on canopy cover and the 3 tree rule, this follows on from the results for these 2 components nicely. And so this is my last slide to summarize and just discuss what these results mean for policy and practice. The 330-300 rule offers a straightforward framework to guide urban greening, but the methodology used can impact the results. So to track changes over time and compare cities, a consistent methodology must be used. Secondly, inner city areas perform worse at the rule, and this is often linked to higher levels of deprivation. And so 330-300 results should be combined with deprivation scores to identify where urban greening is most needed. Thirdly, tree density in private gardens is the most important land use variable assessed for the 3 tree rule. So tree planting in private gardens should be encouraged and the removal of private garden trees discouraged. And then finally, woodland cover is the most important land use variable for canopy cover in an LSOA, and canopy cover is the least achieved component of the rule. So we need more woodland areas, and this requires long-term planning to identify locations and to ensure successful woodland establishment. So that is everything from me, but just to say thank you to the White Rose Forest for providing access to some of the tree data used in the work as well.
Thank you very much, Elle. Another great presentation. So I will hand over swiftly to, who's next on our list? Mahtab Shiravi, who's joining us from the University of Florence. So we're going international now with our researchers. Mahtab is looking at multi-risk analysis of wind and rain for urban trees. Over to you, Mahtab.
Thank you very much for the introduction. As you said, I'm going to present my work on multi-risk analysis of wind and rain on trees in urban environments. Other presenters already explained that urban trees provide a wide range of ecosystem services, but we consider them as vulnerable components of urban landscape. Their growth and stability are often compromised by constraints such as limited rooting space, compacted soil, and surrounding impervious surfaces. These conditions not only restrict tree development, but also amplify their sensitivity to external stresses. With the intensification of climate change, the frequency and severity of environmental hazards, such as extreme winds, intense rainfall, and prolonged drought, are expected to increase. These hazards pose significant risk to urban trees, potentially leading to mechanical failure. That could be uprooting, stem breakage, partial damage to trees like breakage of a branch. And it poses a risk as it has some consequences to roads, to people and their property, to utility lines. It might cause road closure and different types of problems in the city. an urban environment. Climate change is increasing the chance of multiple climate-related hazards occurring simultaneously and consequently making multi-hazard conditions more frequent and complex. The interaction of multiple hazards such as wind combined with saturated soil from the heavy rain further complicate risk dynamics and challenges conventional risk assessment frameworks. From the engineering point of view, when we deal with a complicated problem, we try to make it simple in a way that we try to estimate the real behavior that we observe in the nature and try to keep it simple in a way that we try to evaluate it with the tools and methodologies that we have available in hand. For this problem, we developed two simplified models, one for the above ground part of the tree that we called it above ground model, and one for the below ground part of the tree that studies the soil and root interaction. The above ground part evaluates the acting force on the tree and how much rotation it creates at the base, and the below ground part evaluates this root and soil interaction and how much this system can resist against the lateral loads like wind force. For the root and soil model, we looked at the literature. Most of the works that we have found used simplified plate model on the surface as a representative of the root system. Now, these kind of models don't show the correct mechanism and interaction between root and soil during uprooting. There are also some very exact models like the work of Yang in 2014, which is an exact model of the root system based on destructive field tests. When we deal with lots of trees, we cannot do lots of destructive field tests even in one type of tree. From one tree to another one, this geometry can change, and there are lots of uncertainties related to all the environmental factors affecting tree growth, and we cannot consider them in all of our analysis. So we decided to develop a new model that better understand this root and soil interaction or mechanism and estimate the soil failure path. Besides, we wanted to also consider all these uncertainties that we have in the tree root shape and also the mechanical properties. In some papers, we found out that tree branches can follow something called fractal theory or recursive pattern, but it also has been discussed that trees can have a sort of competition for growth between the branches, and an algorithm called space colonization algorithm, or SCA, has been introduced for modeling the tree branches. We use the same technique for modeling the roots. In this algorithm, we first define a boundary that roots are going to grow in it. The shape of this envelope is flexible. Here you see a semi-ellipsoid form. The shape can change for different tree species, or when we have some barriers like pipelines or infrastructure in the cities, we can change the shape of this boundary condition. Then we put n number of points inside this envelope. The position of these points can change. We randomly distributed them in the envelope, and they lead the root growth inside this envelope. Every time we run the model, the position of these points change, the root configuration will also change. And it's an iterative process, starting from the surface middle point of the envelope, and it grows in each iteration. It's something that we define the number of iterations, and we can control how much these roots are allowed to grow. Then we scale the diameter of the roots in a way that the biggest root, which is connected to the collar area, has a diameter equal to the diameter at breast height of the tree, which is called dBH. And this code that we wrote is Python scripting, which is transferred to a software called Plaxis. It's a software that we model root and soil in it. It's a 3D software, and we can see when the wind force is applied to the system, how soil might fail, which branches of the root might fail, and it gives us a better understanding of this root and soil interaction during uprooting. We also saw that the modeled root system shows us uprooting behavior that we have observed in the real problems, I mean real uprooting trees. When the horizontal wind load is applied, roots in the windward side experience tensile forces as they are drawn away from the prevailing wind direction. In contrast, on the leeward side, roots and soil undergo compression, stabilizing the tree against the wind. As the tree initiates its tilt, it rotates around the fulcrum on the leeward side, known as the hinge. As I explained, the position of those points that we call them attraction points are random, and every time we run the model, the position of them change, the configuration of the root system will change. So we kept all the parameters of the root and soil constant. We just defined different root ratios, and for each of these root ratios, we allowed the model to run 10 times to see how much variation we get in our outputs, which are stiffness at the base of the tree and also bending moment, I mean the maximum moment that the tree might fail in it. So in case later we are going to use this technique in real case studies, we should consider we don't have one result for each tree. We have a sort of variation that comes from the uncertainties we have in the model. And we are able to consider the effect of rain in our finite element model. So we define different scenarios, two extreme scenarios for dry soil and for fully saturated soil. We also define some rain values, different rain values to see how much rain during 24 hours of rainfall can affect the soil saturation and pore water pressure. And you can see the effect of that in moment rotation curves. We have also a simplified model, as I said, for the above ground part of the tree, which has a distributed mass of the trunk, concentrated mass of the canopy, and equivalent spring at the base. The behavior of this spring comes from the below ground model that I already explained. We divided the wind force on the tree into two parts, wind on the canopy, wind on the trunk, and I cannot go to the next slide. Sorry. And we also calculated the wind force on the tree for static and dynamic force, but as I explained, the stiffness at the base, I showed you the curves, moment rotation curves has a nonlinear behavior. So we decided to consider this nonlinearity by defining a technique called linear stepping analysis. We update the stiffness for different forces to reach correct the stiffness for a specific load on the tree. And at the end, we have defined this framework for fragility analysis of the tree. We have a population of trees, and we use them in our above ground model that I have already explained. Based on two limited states for uprooting, we first control if trees are uprooted or not. Otherwise, we check for the stem breakage. For different scenarios of the rain on the soil, we can calculate the fragility curves, and these can be applied to the risk frameworks for creating risk maps in the future. Thank you for your attention. If there is any question, I would be happy to respond.
Thank you, Mahtab. I think there's been a lot of conversation in the chat which you can take a look at, and we'll have some questions at the end for everyone. So I have to hand over next to Madeleine Tate from Newcastle University, and she's been looking at peri-urban strategies for sustainable surface water management. So thank you, and over to you, Madeleine.
Right, I'm hoping you can see that. Hello.
That was there, thanks.
As our cities face heavier rainfall and increasing flood risk, the humble tree could be a part of the solution. Hi, I'm Madeleine, a PhD student at Newcastle University, and I'm researching peri-urban strategies for sustainable surface water management. The aim of the research is to explore the potential of trees in optimizing systems to reduce surface water flooding within an urban environment. To provide some context, the Environment Agency within the National Assessment of Flood and Coastal Erosion Risk in England has stated 1 in 4 properties will be at risk of flooding from rivers, the sea, or surface water by the mid-century, with 4.6 million properties currently deemed at risk of flooding. Surface water flooding affects everyone, damaging homes and businesses, as well as disrupting transport networks and essential services across communities. Cities like Newcastle upon Tyne have been struggling with flooding and its effects for years, with factors including climate change and urbanisation increasing the risk of more frequent and large events. Projects like Blue-Green Newcastle are becoming more important. This scheme is run by Newcastle City Council, which I'm partly sponsored by, Northumbrian Water and the Environment Agency, but it also has involvement from many stakeholders across the city. Projects like Blue-Green Newcastle aim to reintroduce nature back into the urban space to support the traditional drainage systems. They aim to not only manage and slow water down, but introduce multidisciplinary benefits to the area. To find out more about this recently launched project, you can go to their website or scan the QR code to access it. A sustainable drainage system or suds planter is one method that can be used to slow water down. As part of my research, I've constructed a sud planter which is located on university campus. Rainwater drains from the roof, which goes through it, slowing down due to the different internal layers. This water then passes through the outlet and goes into the traditional system. The planter is monitored with rain gauges used to understand the inflow and outflow. It's also being monitored using a flow gauge. Although this planter was constructed on the 1st of May 2024, this graph shows the flow in July for one event, classed as such due to there being a rainfall event and then no tips from the inflow or outflow for 1 hour. The data here and across the monitoring period evidence the effects of these systems, with the peak flow in the events being reduced. The reduction in the peak flow indicates a delay in the volume of water, which allows the system to cope due to the volume of the water being distributed over time. Another element of my research is monitoring trees. I chose to monitor trees as we start to see projects, including Blue-Green Newcastle, lean into the multifunctional benefits which trees can provide. However, my research focuses on the flood reduction potential of trees. Though there are plans to monitor other trees, I'm currently monitoring a tree at the National Green Infrastructure Facility, a living lab within Newcastle. The tree I'm monitoring is planted within a rain garden, another similar type of system used to manage water. This tree has several sensors placed on and around it, which all help to understand the interaction between soil, plants, the atmosphere, and water. The main sensor used is a sap flow meter. Sap flow meters have 3 needles that are inserted into the tree trunk. With heat produced by the central needle, temperature is used to understand the flow of sap. This can be converted into water demand, which once evaluated can provide an assessment of the tree's impact. Sap flow can be compared to air temperature. This can be seen in the graph, with the green being the sap flow and temperature in blue measured close to the site. Current sap flow data collected shows the fluctuations in flow over time, with peaks being seen during the day. These peaks correspond to periods of increased temperature and sunlight, which drive higher transpiration rates and consequently increase the tree's water demand. But this can't be interpreted in isolation, as other variables must also be considered. So the sap flow data must also be used to better understand the relationship between the tree and other weather variables. This will help understand the favourable conditions. This graph is an example of this in practice, showing the relationship between the sap flow and rainfall to start to understand the relationship between the tree, the weather, and flooding. To start to understand these relationships, other sensors are also placed on site using a GPT data logger to collect data, both water potential sensors, which indicate the water available to the plants, and water content sensors, which measure the amount of water in the soil, are also used to monitor this tree. This diagram shows that the sensors were placed into the space with 3 banks of sensors, each with sensors placed at 3 different depths, which are used to understand the flow of water across the space. This sap flow versus water content graph starts to show the relationship between the tree, soil moisture, distance, and time. However, at least a year's worth of data is needed, along with the understanding of other weather variables, to fully understand the soil-plant atmosphere relationship, mainly due to the seasonal changes and these factors being interdependent. As a side note, the soil moisture is also being monitored with the sud planter, meaning there can be a comparison between the tree and non-tree sites. From findings to action. Next steps for this research includes evaluating the impact of the site and policy, as well as developing a sud planter to tree connection, which will look at disconnection via the outflow of the sud planter being directed towards the tree. This step aims to optimize these elements when it comes to managing larger events, particularly in the winter, which is when these systems are not expected to cope alone. I'm also looking at other sites to monitor. This will provide the opportunity to include looking at other variables, including tree age and location, but this research is limited by number of sites that can be monitored, so there's only a limited number of tree species or deciduous that will be selected. The town moor in Newcastle is one site that's going to be monitored, also home to Blue Green Newcastle's pilot phase. This area has mature trees and trees recently planted by the North East Community Forest and volunteers, providing a space that is a peri-urban site, which can be used to assess the extent of the age of the trees impacts the tree effect on the surface water flooding. Other sites will include those on university campus, which will help explore different site types within an urban setting, including tree pits. I am monitoring and exploring a sud planter and trees of various ages at different location types, and I also have plans to look at policy. But what does this actually mean? The data collected and sites developed show this working in practice and help to understand why this is providing that trees and sud planters can play an active role in managing surface water. This evidence creates space for informed evidence-based decisions to be made. When paired with an understanding of local policy, it also allows practical targeted recommendations that directly support stakeholders to be developed. This research provides a pathway for projects like Blue Green Newcastle to lead in climate-resilient urban design, where every tree planted becomes an active part of the city's drainage network. And that's it from me. Here are QR codes from throughout the presentation, as well as one for my LinkedIn and emails at the top, so please don't hesitate to reach out. Thank you for listening.
Thank you very much, Madeleine. Another excellent presentation. And everyone's doing so good, keeping to time as well. It's brilliant. So I'm going to now hand over to our last speaker for today. So another international presentation for us, this time from Jackie Hamilton, who's joining us from McGill University in Canada. And she is going to talk about the benefits of emotionally engaged care for trees. Over to you, Jackie.
Wonderful. Thank you so much for having me. I'm very excited to be with this group and a bit envious of the group that you have established in the UK. Okay, so I am doing a PhD here in Canada at McGill University, which is located in Montreal. Here's a photo on the left to prove that I did fieldwork as part of this PhD. But the photo on the right here is showing me about 10 years ago when I was doing my master's program, and I got the great pleasure of going to the UK to do an internship. And here in this photo, you might recognize this tree. They're pretty famous. This is King Offa's oak, which is on the Windsor Crown Estate, and it's a pollarded oak that is, I was told, over 1,300 years old. And so this tree, because it is pollarded, we know that it's been managed for many, many generations. Just think about the many, many people that have seen this tree and interacted with it, perhaps even some famous monarchs, certainly the current monarch. And this tree is kind of a living embodiment or a story that tells about the human relationship that's happened over many generations. And this kind of relates to my research, so I thought it was a good story to start with. So for anyone who hasn't been to this part of the world, the landscape that I was doing my PhD in is called the Mont Saint-Hilaire Biosphere Region. It's just outside of the city of Montreal, and it looks kind of similar to the landscape that I worked in when I was in the UK in Herefordshire. There are pockets of urban and kind of village settlements, and then there's also patches of private woodlands, people's back gardens, of course, and also agricultural land. And these photos are showing just like an example of some of the plots that I went out and measured trees in. I put random plots across this biosphere region, went out, measured the trees, and also invited people who were responsible for those trees to talk to me, to do interviews, to talk about their relationship to trees, the benefits that they saw from them, and the ways that they took care of those trees. And the trees were both inside and outside of forests, and also on public and private lands. And like my title kind of implies, I'm really interested in these personal and emotionally engaged relationships that people have with trees. So these personal relationships aren't just nice feeling, although they are really important for people's well-being. Actually, this connection to nature, I'm sure we all know, is really important. But they also help co-produce ecosystem services. So all of the benefits that come from trees, especially in cities, are also co-produced by the people who are tending to those trees. If someone plants a tree and takes care of it over many years, all of the shade, all of the water that's provided by that tree is partially provided by that person too, right? Because that person put effort into making sure that tree thrived and survived. And these relationships, they influence, of course, the benefits trees provide, but they also influence the biodiversity on the landscape itself. And a great example from the region that I was working in is the sugar maple. So this is a tree that's incredibly culturally important in this region because it's the tree that we tap to get sap and boil down and create maple syrup. And this tree is being tapped across the landscape, not just in woodlands, but also in people's back gardens. People are teaching their kids how maple syrup is made and passing that knowledge along down generations. I think there's kind of a similar synonymous relationship in any place that you go to with particular tree species. And this is often called like a biocultural relationship. So one of the examples that I was thinking of in the UK, trying to bring a kind of local example to you, in Herefordshire, there were coppicing of sweet chestnut, and the chestnut was used for fence posts and other kind of traditional crafts that both create the benefits that are coming from the tree, but also shape the landscape. You can go into an area and say, I see that someone is collecting sap from this tree. I see that someone has coppiced this tree. And that tells you a story about the benefits that have come from that tree. And as I mentioned, this is also influencing the biodiversity on the landscape itself. So not only is it co-creating benefits, but it's also co-creating the ecology of the place itself. You can think of the ways in which we care for young trees and how that might help that tree survive and thrive in a place that otherwise might be really harsh, like a front garden that's right on the roadside, like this little tree here. What we found from our tree plot data is that the private gardens, the private areas, the private lands and woodlands, they tended to have more diversity. They had more diverse species, but they also had more very small and very large trees. And I think a lot of us know that those are the more vulnerable trees in a population, the very small and the very large. And this data is just showing you what I just said. And I won't get into it, but you can take a look at the PDF after, which I understand will be published on the website if you're interested in looking. And this paper is in review and hopefully will be published soon. And this pattern has also been seen in other places. So in London, in Hong Kong, there are similar patterns where people's private gardens are providing a lot of diversity. They're kind of a refuge for tree diversity and for canopy cover. So the question becomes, why is this the case? In some of these studies, there are great hypotheses about the kind of conditions that support diversity, as well as a hypothesis that the preferences of private landowners really drives this diversity. So what I found that was quite interesting in my interviews is that public land managers often told me that biodiversity was their preference. You know, they recognize that biodiversity is really critical to resilience of our urban forests. And private land managers didn't really talk about biodiversity much at all. I mean, they talked about wildlife and supporting wildlife, but diversity of the trees itself was far less talked about. And instead, they talked about things like their relationships with their children, relationships with places that they lived before that make them want to plant certain species, or their neighbors. And all of these relationships were really influencing how they were selecting species and how they were caring for trees. So when I talk about care, I think it's important to describe what type of care I'm talking about. This actually comes from feminist theories of engaged care. Fisher and Tronto say that there are 4 components of care. So caring about is recognizing the needs of another. And though these theories come from human relationships, they also are applied or can be used in kind of human nature relationships. So caring about is saying, I recognize that the tree has needs that need to be met. It needs certain resources. When it's young, it often needs water, for example. And then caring for is this taking on of responsibility. So not only do I see that the tree has needs, but I also know that it's my responsibility to help it meet those needs. Caregiving is the actual act itself. So I worked for a while in an NGO, and I know that caregiving can sometimes be misinformed. For example, watering a young tree too much can be a problem. But caregiving is the actual act, and care receiving is monitoring how did the tree respond to that care. And what was super interesting in the interviews is that caring about trees was ubiquitous. So both the private and the public land managers, they really cared about trees. They recognized that trees had needs. The private landowners told us that trees needed certain things. They needed to be watched. They needed to be watered when they're young, for example. And many of them told us that they took a lot of pride in giving this care. So not only are they recognizing the needs, but they are giving care and they're monitoring those trees to see if they're thriving. Now, on public lands, there's kind of some barriers that were mentioned in terms of giving care. And these include the fact that they're responsible for so many more trees than private garden owners, right? They have many, many parks and streets that they're responsible for. And this sometimes stopped them from planting trees. For example, in this quote here, you see that a park manager didn't want to replace a tree because they were concerned about vandalism. Now, if someone who really cared for a tree or a place was nearby, I think vandalism, the risk of vandalism is somewhat lowered. And this is kind of just one example of many of the differences in care between private and public lands. Okay, so we know that trees provide many benefits in our urban areas and that promoting the health of trees helps promote the health of humans. But I think there's also a way in which people promoting the health of trees immediately benefits people in terms of their emotional well-being and connection and relationship to nature, but also to the trees. And so this really lovely idea from Claudia Camberti back in 2015 of services to ecosystems, I think can help us consider how are our policies and designs supporting trees in thriving in the places that we live. And a second consideration that I would love to hear from you all about is how we can help support good and effective caregiving through best practices, et cetera, and move perhaps away from trying to convince people to care about and toward better caregiving. And with that, I will thank you so much again for the invites and just thank all of my collaborators.
Thank you very much, Jackie, for your presentation. Very thought-provoking. We have a few minutes now for questions. I know there's been an awful lot going on in the chat. If anybody has got a question that they would like to ask to one of our researchers, then please raise your hand. There's lots of clapping going on. Has anyone got a question that either needs expanding on a bit, the answer that you got in the chat, or you'd like to ask directly to one of our presenters? Okay, I think, Sue, you've been monitoring the chat. Most of the questions have been answered.
I think most of the questions have been answered. I mean, I was very interested in Mahtab's presentation about whether by able to test the sort of structural strength of a tree, you'd actually protect trees that might otherwise have been automatically felled as being deemed weak. I mean, is that one of the outcomes that can be achieved?
Excuse me, can you repeat your question?
Oh, sorry, by being able to test the strength of the tree, which is what you described to us, has that helped trees remain in place, which otherwise might have been deemed to be unsafe and therefore felled?
Yes, exactly. What we did, we developed a finite element model that we studied the effect of rain on the stability of trees on the soil. Of course, as you said, when the saturation is higher, the root system will act weaker and it affects the stability. It's more probable for the tree to be uprooted. And also soil properties affect. The other thing that might be effective is the root configuration and its shape. If it's deeper, if it's more shallow, all of these affects the stability of the trees that we are able to study with this developed methodology or framework.
Thank you.
I had more. I had one for Jackie, which I just so like the idea that trees have needs, because I have this theory that trees have rights and we ought to respect them and so on. So do you think it kind of also links to the questions of benefits of trees and with private landowners, as Elle described, and so on? How can we really get, I think here we don't have enough people really actually loving them and wanting them so much. I'm just trying to think how we can actually make the case that trees have needs, and so you all need to start respecting this.
Yeah, that's a really interesting question. I think in some of our cities, at least here and probably everywhere, there's a disconnection from nature that stops us from seeing the needs of trees. And so I found in my interviews that even in the very urban areas, people cared a lot about trees in general. You know, they really respected them, but they didn't necessarily know what the needs of trees actually are, that they have roots, that when they do construction, it's going to impact the tree. And so I heard a story about someone who they regraded their backyard and they had all these beautiful mature maple trees, and then they started to suffer and they spent many, many thousands of dollars to correct the grading and to save the trees. And I think that's one case that's kind of quite rare. I think often people just don't recognize that trees have the types of needs that trees have.
Can I ask Isabella a question?
Yeah, if we've not got any other raised hands.
Do raise your hands and put your... So Isabella, I'm fascinated by your presentation on limb arborists, because having struggled as an architect with BIM, but is it a sort of methodology and a way of working that would be quite easy for other offices to quite readily adopt, or does it involve a kind of training in use sort of process?
Well, yeah, that's a good question, Sue. I mean, I think that's one of our focuses, that we've really been keen to try and find a sort of seamless way to integrate. But obviously, I do find that there's a concern, especially in the landscape architectural profession, that we have a tendency to doing 2D work and not necessarily move ourselves into 3D. I don't think it's because we don't want to, but there's definitely a gap in the education, I think. But what we're trying to do is, as long as you start having these 3D digital software skills, LIM is a very simple add-on to that. So the upskilling lies actually more in the learning those 3D softwares that anyway is in conversation with other disciplines like engineers and architects that are already using them. And hence LIM is just an extra layer that comes quite naturally with the software. So it's embedded into the software, all of that data and the simulations, which is what we think is important as well. Yeah.
Okay, and Will's not off the hook. Oh, Emily's got a hand up. Emily, you go ahead. I don't need to have the stage.
Thank you. I actually had a question for Isabella, in that I really like the idea of digitising these spaces, particularly because I work in planning and sustainable development. It's a real challenge to try and get local planning authorities here to really look holistically at a space in that way. And I think that's absolutely brilliant. But do you think that this could be connected to other spaces? So it wouldn't just be within one particular project. You'd be able to link all these projects up to be able to go to make a more overview of a whole city, a whole area, get that connectivity going.
Yeah, so LIM in itself can scale up all the way up to regional, even larger scale interconnected sites. I think that's definitely a desire that we want. The idea is also that you in some way give the model back to the councils or the authorities that we worked with, for them to have sort of an archive and for them themselves to generate and follow through over years. But I can definitely see that there is a potentially a challenge, because obviously we are, as consultants, pretty strictly refined to the red line boundary, but landscapes themselves don't have a boundary, right? They work across. So what we try to do is sometimes implement larger scale outside of the red line boundary to kind of show how it all is interconnected. But I think it would have to have a sort of an input from different actors in the game, both the authorities being willing to maybe perhaps wanting that larger scale interconnection. But ideally, that's how we would see it. I completely agree with you. I think it should be a lot more than just a red line boundary.
I see this approach being absolutely excellent for local plans when you're looking at an entire region of, their housing needs, as well as putting in green infrastructure and everything, and just how wonderful it would be to have something like that to play with. It'd be excellent. Thank you.
Yeah, absolutely. And just to sum that up, I think what the amazing part is that you can give back to the public, right? You can also, as an authority, showcase how much are we doing by just maintaining it and ensuring that this landscape is integrated in our planning.
Yeah, great. Thank you very much.
Thank you.
Thank you. And we've got a question from Anna.
Hi, thank you. So a question for Jackie. I was just interested to know whether in her conversations with all those tree carers, whether she found that there were particular sort of critical factors or conditions that allowed people to engage with a particular tree or care for a particular tree. So was it proximity to where they lived, or had they been involved in planting with it? Were there sort of key things that we can then bear in mind when we're trying to engage other people in trees?
Yeah, thank you for that question, Anna. I think there are many factors that can inspire people to care for their trees, but we certainly heard that if someone had a personal relationship with the tree, like they planted the tree or had some childhood memories with it, that definitely created this strong connection, but also relationships to others. So relationships, like I mentioned, cultural relationships were also really important. So if it was a species that was culturally important, people recognized it as like really important, and they felt that they had a really valuable tree. I was speaking mostly to private landowners, so they owned the land and that was their connection. So most of them lived in proximity. And that was a difference we saw with the public land managers, where often they didn't live with these trees, right? They were responsible for street trees across the entire city. And so they didn't know the trees on kind of a personal level, because that would be impossible to know every street tree.
And so did you have a question for Will?
I had one for Will. We've been going back and forth a little bit in the chat on this, Will, but what the work you're doing at the Mersey Forest, we were talking about the importance of the local and tree species selection. So is your approach going to be transferable so that, somebody in Southend or Southern England or Northern Scotland can kind of apply what you're finding to their work?
Yeah, so that's a really good question. So it's something obviously that in a perfect world would be able to kind of spit out a kind of output and say it works here and therefore we're going to use it somewhere else. But as I'm sure we all know, if you look at kind of like the mortality and health outcomes kind of across the country, we're seeing massive differences. So kind of the goal kind of in my research currently is, just focusing on the Mersey Forest for now and really kind of honing that down and making sure that it works. But I don't see any reason why not but then research could kind of go beyond that to kind of like expand it into other areas. But I think fundamentally, because it's all kind of so location specific, we might be able to get some generalizable guidance out of it, but kind of I'm really trying to hone in on kind of making kind of the Mersey region kind of currently kind of the best kind of urban forest we can make it.
Okay.
Right.
And I was thinking with Ellie's comment, I just wanted to say 2.1% of buildings in Manchester meeting the 330-300 rule, I thought was quite worrying. How are we going to change that?
Yeah, it's really worrying given that that was the highest result out of the whole study. Yeah, how we're going to change that is a really big question. Obviously, hopefully some of the results from my work can help encourage those changes that we need to see more progress in each component of the rule. More trees in private gardens and woodland areas.
It was the 30%, was it, that was letting most of the cities down in the rankings, I think.
Yeah.
Did you do any analysis where you were seeing, you know, what criteria what percentage would we have to get to where we started to see a higher pass rate? Like if it was 20%, were we getting more areas through, or, you know, where were we starting to?
I didn't.
What level of uplift would be
Yeah.
needed?
Oh, so as in how much more canopy would we need, or what kind of lower level would we need to see success?
Yeah, where are we starting to see a sort of higher pass rate, if that makes sense?
Yeah, that makes sense. So I didn't do that kind of exact analysis, but I did obviously get the canopy cover results for each of those local authority areas that I looked at. And this is just from memory, so this is not the actual results, but I can't remember many of them being above 20. I can remember York in particular had really low canopy cover. So I would say, yeah, it would be somewhere between 10 and 20 where we'd start seeing the better results.
Okay, thank you. So I don't think we've got time for any more questions now. We'll move on to our voting. So I think you will see a poll appear. And if you can have a think about what you've heard from our 6 presentations today, the wide range of research that they're all doing, and scroll down the poll and choose which is your favourite. So we're looking to find one to win the Early Career Research Prize. Give you a few moments to cast your votes. Okay, it looks like it might have come to a close there with the votes. Have we? Oh, we've still got a couple coming through. Just give it a couple of minutes. Okay, I think it's maybe safe to announce the results now. So I think we were going to have 2 runners up to the prize. So coming in 3rd place, we have Isabella Bhoan. Congratulations, Isabella. And then 2nd place, we have Will Leaning. So congratulations to Will. And our winner today of the Early Career Research Prize is Elle Smith. So many congratulations to Elle. So I would just like to say, yeah, Sue will be in touch with you to sort of share the prize with you. But I really wanted to thank all of the researchers today who've put forward their research and presented to us. I didn't get a chance to vote, and I'm really not sure who I'd have voted for. I found them all fascinating, all very different and very varied. And yeah, just amazing the work that you're doing. So thank you very much for participating today. I hope you found it a really enjoyable process too. And it would be great to keep in touch with your research and how you get on with your findings. I also wanted to thank everyone in the audience for joining in, for engaging in the chat, for sharing your thoughts and dialogue. I think I'm going to be spending a good few hours trying to catch up with what's been going on in the chat. And many thanks to TDAG for putting on this seminar. They always do such a brilliant job, a lively, engaging series of seminars. So I'm sure you all agree. And yeah, I think it's over to you, Sue, now to close us up today.
Well, thank you, Susanna, for your excellent sharing as ever. And we do actually have a research resource page on our website. So when people have finally got their final things, we're always very happy to host those. So our last seminar for this year will be on the 9th of December. Cecil's already mentioned ENG. In fact, I heard somebody today also talking about the more important environmental net gain, but just focusing on BNG. We're going to be looking at resilience through BNG. What have we learned in England? A 2-year review. So I think that will be quite timely on the 9th of December at the same time. And it will, of course, be on our website. And of course, Dee will send you things out. I will go through the chat and try and link answers to questions, and hopefully in some sensible way, so that with the presentations and the recording will all be on our website and you can all have a chance to see it all again. So thank you all very much, and tea time again.